Hello, everyone. I'm Gizem Ganalaka, the Technical Area Coordinator for Stantec's Climate Risk, Resilience, and Sustainability team in Ontario. Thank you for joining Stantec for today's webinar for Net Zero Emissions and Climate Change Resilience for Manufacturing. Before we get started, there are a couple of housekeeping items I'd like to go over. All participant audio is muted during the presentation. If you have a question, please type it in the questions panel on your webinar dashboard. Questions will be answered at the end of the presentation. And today's webinar is being recorded, and a copy of the presentation along with the supporting materials will be sent to you afterward. Those of you familiar with Stantec know that safety is a critical component of our business. We start every meeting with a safety moment. Last week was Railway Safety Week in North America, so today I'd like to share a few tips on railway safety from Operation Lifesaver. It takes the average train at least 2 kilometers before it can come to a full stop. Because of their size and the way they approach you, rail cars can seem like they're moving slower than they actually are. Rail cars can extend 3 or more feet beyond the rails. You're not safe just because you're not on the tracks. So be alert and never walk on tracks or take any chances in the presence of a rail car. In today's webinar, we will explore environmental social governance and climate change risk, pathways to net zero emissions, and building resilience to the impacts of climate change. But first, let me introduce you to today's hosts, Nicole Flanagan, Vicki Corning, Antonino Lagana, and Norm Shippey. Nicole Flanagan is a climate change and sustainability subject matter expert who has over 20 years of experience in consulting and government. She has worked across all sectors, from very detailed facility assessments to strategic advisory services at the corporate level. Vicki Corning has 16 years experience in greenhouse gas emissions management and climate change policy related to consulting services, including working for a variety of manufacturing clients and other industrial and government organizations. Antonino Lagana specializes in energy efficiency, green engineering, and sustainable development. He has delivered countless feasibility studies from design through commissioning in the industrial, commercial, and institutional sectors. Norm Shippey is a senior climate scientist and the Canadian technical lead for climate vulnerability and adaptation for Stantec. He has over 12 years of experience and has worked with clients from the international, federal, provincial, municipal, and private sectors to improve climate resilience for their business needs. I'll now pass it over to Nicole, who will explain environmental, social, and governance and how it relates to climate change risk.
Thank you, Gizem. So often you'll hear the term ESG. ESG stands for Environmental, Social, and Governance, and these are topics that pose an opportunity or risk to an organization. Under environmental, we often have things like biodiversity and carbon footprint, energy and water use. Under social, we have things like diversity and inclusion, safety, employee retention and attraction. And under governance, topics like anti-bribery and corruption. We know that there's an increasing pressure for corporations to align with their ESG values with those of their stakeholders. And it's important that companies begin to manage, set goals, and report on material topics. The steps in the ESG process are really to understand your stakeholders, to understand what is material to you as an organization and what is material to your stakeholders. And that begins by identifying topics, prioritizing those topics, and validating and reviewing those topics on an ongoing basis. The next step is to develop a sustainability framework, and that defines the sustainability commitment or vision of an organization, sets the focus areas on those material topics, and sets goals and a pathway to achieve those goals. And finally, there's the reporting to stakeholders, and that is a communication that is meant to engage stakeholders and report on the material topics developed in the first part of the assessment. We want companies to begin to look at sustainability not as a cost proposition, but as value creation. Sustainability can improve things beyond the topic that you're looking to manage. It can drive customer loyalty. It can improve employee relations and attraction. It can drive innovation and result in positive versus negative media coverage. It also drives operational efficiency and is a great risk management tool. All of this can drive greater profitability and higher corporate valuation. As well, lower the cost of capital. We know that banks are considering sustainability and climate change risk in their lending portfolios. And all of this is to derive long-term value and creation for shareholders and society versus the more traditional quarter-to-quarter performance. And so let's look at some of the drivers in the manufacturing sector. There are a number of customers that are imposing supply chain requirements. So these actions are being pushed down through the supply chain. Things like emission reductions or renewable energy, or having an ESG program to simply get access to tender documents. We also know that investors are looking for more sustainable investments. We know that carbon can increase operating and supply chain costs as carbon legislation and the cost of carbon may be something that companies are faced with in the future. We also know that the Task Force on Climate-Related Financial Disclosures, or TCFD, is becoming more and more a part of everyday business. And in that case, companies are beginning to examine their transition and their physical risk. And these are being undertaken on a voluntary or driven by the security commissions as a mandatory reporting requirement. So let's look at a few examples of climate change risk and opportunity. Under the transition side, or the risk related to transitioning to a low carbon economy, we see things like carbon costs. Carbon costs can have some significant implications on a business, not only within their own operations, but within the supply chain itself. Companies need to begin to look at opportunities to reduce greenhouse gas emissions, not only within their own operations, but within those that they do business with. And this can often drive innovation to recognize those high return on investment opportunities and better position a company versus its competitors that continue to operate business as usual. We also know that there's a number of behavioral changes that the transition to low carbon economy may bring. So for example, customers may choose to buy electric vehicles versus more traditional internal combustion engine vehicles. And that may pose a risk to manufacturers of components that are strictly related to a combustion engine. On the physical climate change side, we know that assets and infrastructure typically is exposed to extreme weather events that are anticipated in many cases to become more frequent and more extreme in the future. And understanding the risk on those assets is key to identifying adaptation measures to build in resilience into operations. And we see that not only within the infrastructure and assets of a company, but within supply chains as well. Some of the key risks in the manufacturing sector that we're seeing is the physical climate change risk. So how operations and supply chains may be interrupted by extreme weather events, rainfall, winds, shipping routes that go through areas that are prone to extreme weather events, as well as greenhouse gas emissions and the potential cost of carbon. Again, these could be facility emissions or within the supply chain itself. So one of the examples here is steel. Steel has a carbon footprint of approximately 1.6 tons of carbon dioxide equivalent for every ton of steel produced. And while that may not be impacting a manufacturer's operations, it is impacting the supply chain. And there is a cost of carbon associated with that material being produced elsewhere that may be passed along the supply chain. So why the pressure on manufacturing in particular? And to really answer that question, I think it's important to look at the emissions breakdown for a large retailer or a large corporate client. And if we look at the graph on the pie chart on the left, we'll see that, traditionally the scope 1 and scope 2 emissions that a manufacturer would be responsible for are really a small piece of the pie, with the majority of emissions being scope 3, or those outside the facility, but that occur as a result of facility operations, or the products that facilities are producing. So if we further break down those scope 3 emissions, we can see that purchased goods on the right pie chart represent a large portion of the average end product. And so companies are really looking at their entire greenhouse gas emissions, and they're setting targets, and they're going to use that influence that they have to make commitments and to push that down their supply chain. So in this case here, we've got a chart that just shows how the cost of carbon and the risk related to climate change at the base there in that raw material production is quite large, and it essentially flows up through to that final corporate customer. And that brings with it the risk of increasing cost related to carbon, the increased risk related to climate change. And so that corporate customer is looking to implement risk mitigation measures down its supply chain. And so the corporate customer is really starting to ask things like, do you have ESG requirements in order just to access basic tender documents? We're also seeing them look for climate change risk disclosures, so CDP or TCFD. A number of them are asking or mandating the setting of science-based targets. And we're seeing that as companies begin to scramble to meet the requirements of their large customers. They're also asking about risk oversight. Is it at the board level? They want to make sure that the risks within their supply chain are being managed. We've also seen a number of companies that are looking for commitment to use renewable energy within the supply chain. So not just at that first level of manufacturing, but 2 or 3 tiers down, they're looking to have renewable energy used within manufacturing processes. Part of this, while it is a request to use that renewable energy, it's also a tool for them to identify suppliers that may not necessarily be in touch with where their materials are coming from. And that poses a risk to that corporate client. And so some of the recommendations for manufacturer, if you're not already there already, is to develop an ESG program, to understand what your data needs are and your metrics, which can be one of the largest challenges to overcome. To really set targets around some of your performance issues or your material topics, to develop a roadmap and framework, and then operationalize sustainability by embedding it within your operations. We recommend completing a climate risk assessment, so examining both the risk of physical climate change as well as the transition to a low carbon economy. Engage with your supply chain, understand that their risks are also your risks. Design and implement a governance structure that supports operationalizing sustainability. Take a holistic view of sustainability when developing your return on investment, and develop a net zero strategy and begin to put that into action. And so with that, we have a poll question for you. So I'll just read it. What issues are you as a manufacturer most concerned about? And you can select all that apply: physical climate change impacts, my GHG emissions and carbon costs, meeting customer sustainability requirements, or unknown physical and carbon risks in my supply chain.
Thanks, Nicole. Let's give everyone a minute to answer the question. Here we have the results of the poll. It seems that the majority of participants feel that their greenhouse gas emissions and carbon costs is the topic that's most material to them, with meeting customer sustainability requirements close second. Thank you, Nicole, for your presentation on ESG and climate change risk. Just a reminder to put your questions into the chat box, and we'll have a panel discussion at the end of all the presentations. I'll now pass it over to Vicky and Antonino, who will provide us with a discussion on pathways towards net zero emissions.
Thank you, Gazem. So I'm going to talk a little bit about why net zero has become the goal for the majority of the world in the past couple years, what net zero greenhouse gas emissions means, a general approach for developing a net zero pathway for your company, and then Antonino is going to talk about some practical considerations based on his experience. So net zero has become the new benchmark because although the Paris Agreement doesn't mention net zero specifically, governments have recognized the need for these targets and most have now legislated it. It's the Intergovernmental Panel on Climate Change that has identified this as the science-based target for us to limit global warming to 1.5 degrees Celsius or less. And based on the new science-based targets, reaching net zero by around the middle of this century is going to be a requirement for us. So far, progress isn't on track based on country targets right now and forecasts. We're still looking at warming of over 3 degrees this century. And so more and more companies and individual countries have committed to net zero, but these pathways are just still being developed in terms of how we're going to get there. So what does net zero greenhouse gas emissions mean? The basic definition is that there are no greenhouse gas emissions, or where greenhouse gas emissions are still happening, they're completely offset by other actions to remove an equivalent amount. So in terms of a net zero plan for your organization, there are different levels of rigor that are currently being proposed, with some companies looking at the full suite of greenhouse gas emissions that Nicole talked about a little bit, so scope 1, scope 2, and scope 3, whereas other companies are focusing more on scope 1 and scope 2, where you have more direct control. But as Nicole highlighted, the scope 3 emissions are a key component, especially for manufacturing, where that can be a larger portion of the greenhouse gas emissions that are related to your operation. So things like embodied carbon in your products or your supply chain transportation emissions would be scope 3 that are a little bit more challenging to move towards net zero, but that a lot of organizations are starting to put requirements around and set targets around. You may also hear the term net zero in relation to buildings, and that's typically talking about net zero energy, which is a little bit different in that we're talking about the building not consuming any more energy than it produces, and in some cases, the building may be designed to actually produce net positive energy with the ability to feed electricity back to the grid. So when the IPCC is talking about net zero by 2050, we're looking at the economy as a whole being net zero. And so when we break it down by sectors, there are certain sectors that are already there in terms of electricity, for example. Renewable energy can be net zero greenhouse gas emissions. Hydrogen is another opportunity that can be used for electricity or for transportation that can move us to net zero. In terms of buildings, building a well-insulated building that's run on carbon neutral electricity, as I mentioned, that can be a net zero energy build, but also a net zero greenhouse gas emissions. Some industrial processes can be based on carbon neutral electricity and totally eliminate their greenhouse gases. Now, that being said, there are some sectors that are more challenged in that they have industrial process emissions that are difficult to fully eliminate. Nicole mentioned steel, cement is another one that's typically highly greenhouse gas intensive. So for those sectors that are likely not going to be able to achieve a full net zero greenhouse gas emissions, offsets or sequestration are going to be part of the pathway to get there. So carbon capture, tree planting, or other sequestration techniques will come into play in terms of being able to achieve net zero for the economy as a whole. So one of the key components of achieving net zero greenhouse gas emissions is going to be renewable electricity. And this chart shows where Canada's at now and also provides a forecast out to 2050. Now, this was just from a recent report released to 2020 Canada's Energy Future. And although it's fairly recent, it acknowledges that it doesn't actually go far enough in terms of the renewable energy content to get us to net zero. So if you see natural gas here is still a fairly large component, and that would have to be further offset for us to get to net zero. So I thought it would be interesting to look a little bit at greenhouse gas intensities for electricity production in various states and provinces versus the cost of electricity in those places. So based on some recent numbers, I put this chart together, which shows some higher intensity locations. Saskatchewan, Nova Scotia, Alberta are kind of mid-range in terms of cost, whereas Canada does have some provinces that have either fully achieved net zero or are very close. Manitoba and Quebec with a large proportion of hydroelectric, and British Columbia is also quite low on the greenhouse gas intensity scale, and also lower costs. So those locations are closer to being able to get to net zero on their electricity consumption and have been able to achieve a lower price point. Whereas if we look at Ontario as an example, Ontario's greenhouse gas intensity has come down a lot in recent years with the retirement of coal, but its cost is elevated compared to most other provinces. So I also put on this plot the natural gas price for Ontario with this red natural gas. So here you can see the intensity is quite a bit higher than the electricity available if you were to choose natural gas over electricity. Your greenhouse gases are going to be higher, but your cost is going to be lower. So right now, there isn't sufficient economic driver to push the switch from natural gas to electricity in Ontario. Diesel is also on here as an example and is quite a bit more costly. So the driver there is already evident in terms of electricity being not only more greenhouse gas friendly, but also more economical than diesel. So carbon pricing is to come into play and help us get to net zero. And the way that's going to work is that there is a proposed increase in carbon cost year over year. The numbers shown here go out to 2030. And the 2022 numbers are currently legislated. The other ones are in policy documents, but haven't been fully put into force. But an example here of how carbon pricing is expected to work. When we look at natural gas, assuming a commodity price stays the same with the incremental price of carbon, we're going to see an increase in natural gas cost overall out to 2030. And then just to provide an example of how that will affect the economics of using gas over electricity, for Ontario, the natural gas price now is going to increase and eventually get on par with electricity, presumably, and eventually surpass that because the government wants us to use this lower carbon intensive electricity. And so that's going to be one of the key drivers in electrification of industry to reduce greenhouse gases. So who's made net zero commitments? It started back in 2017 with Sweden being the first nation to put net zero into law. Then by 2019, the UK was the first G7 economy to legislate net zero. In 2020, China, the world's largest greenhouse gas emitter, committed to net zero. They gave themselves an extra 10 years, but they have committed by 2060. And now looking at where we're at now, we have over 2/3 of the global economy having net zero pledges, including over 120 countries, all G7 nations. The United States specifically in 2021, with Biden taking over, has committed to a 50% reduction by 2030, carbon pollution-free power sector by 2035, which will have a big influence, and net zero by 2050. Canada has also made a commitment. As of June of this year, it's fully legislated through the Canadian Net Zero Emissions Accountability Act. And there are a number of initiatives that have come out this year in terms of meeting that target. One of them being that a series of interim targets are going to be set on 5-year milestone increments. And then, as Nicole talked about, a number of private companies and also provincial and local governments have made the same net zero commitment. So in evaluating the different elements of how to get there, there's no single answer. It's going to be different depending on your jurisdiction. Overall, you need to take a portfolio approach, look at the low-hanging fruit, plan based on carbon pricing, grid electricity costs, greenhouse gas intensities, and consider that in your capital planning. Targeted interim greenhouse gas reductions can help show progress and also be able to implement technologies that may be feasible now or some that may not be feasible for 5 or 10 years down the road. The use of both economic and non-financial metrics are important, as Nicole said. And then incorporating resiliency considerations can also be part of the net zero plan. So Norm's going to talk a little bit more about resiliency in his presentation. So the steps in a net zero strategy would include looking at your current emissions and forecasting your business as usual greenhouse gas scenario to the end of facility. So looking at what your emissions are going to be if you do nothing. Now, in evaluating business as usual, you have to think about what reasonable assumptions make sense in your jurisdiction in terms of things like electricity grid changes. How is the carbon intensity of your local electricity grid going to change over the next 10, 20 years? Are there clean fuel standards that are going to come into play that are going to affect the carbon intensity of your fleet? Then you'll evaluate the economic and technical feasibility of various potential actions that may be available to you, both now and with the increasing cost of carbon. And then evaluating risks and opportunities and developing overall recommendations, prioritizing those. And overall, this can be built into a plan and roadmap that can be revisited on a regular basis. So just a few additional considerations. Overall, your net zero plan should be reconsidered regularly for priorities and return on investment with changes of cost of carbon, electricity, and technology advancements. It should include mechanisms to integrate greenhouse gas management into your operations and business practices. So like Nicole mentioned, having upper management commitment and really having staff buy-in for the plan. You need to consider the best available technology assessment, findings, and opportunities, and see how that can be implemented throughout the life cycle of your facility. And then also consider what kind of strategies you can include for partnerships and advocacy for supportive actions by government and stakeholders and potentially industry organizations So things like pushing for low carbon electrification legislation, net metering programs in your area. If you're an industry that needs offsets, working towards a robust offset system and trying to ensure a good supply of high quality offsets might be important to you. So now I'm going to pass it over to Antonino to talk a little bit about his experience.
I'm an energy efficiency engineer with direct experience in energy audits and project delivery. I've worked for clients in every industry, commercial clients, government, and I've got some industrial projects on the go right now. What we do is we make operational zero carbon feasible with return on investment. Our goal is to eliminate the carbon footprint of energy consumption and mitigate the impact of embodied carbon. And we always have an eye on what that means to your business. The bottom line is return on investment, because you have to be able to do that feasibly, and it has to pay for itself. And what we do is we tailor our approach to your energy landscape. Each province has a different energy landscape, and it's defined by the utility rates, which will be influenced by the carbon tax and the electrical grid emissions factor. We develop a plan whereby we recommend and install energy efficiency measures that reduce energy consumption and GHGs, carbon footprint. By means of the energy savings, we get the return on investment. And we couple that to facilities renewal so that you get an even bigger bang for the buck. There's equipment that has to be changed. Well, we're going to change it with highly efficient, brand new equipment that's adapted to today's reality, where clients and partners are hoping that you reduce your carbon footprint. And also because it's more efficient, it's less costly to operate. And because existing equipment is probably at end of useful life, now's the time to change it. Well, we obviously want to incorporate facilities renewal in the big plan to revamp and streamline and improve your processes, as well as get GHG reductions. So energy savings, facilities renewal, but it doesn't stop there. There are also subsidies. NRCan is offering grants, and in some provinces, there are also provincial grants and utility grants as well. In Quebec, Hydro-Quebec offers grants, the provincial government offers grants, and a rebate on clean electricity when we electrify end uses. So all that together provides a roadmap, a plan with return on investment. And we tailor it, as I said, to the energy landscape. There are different types of energy landscapes. There are different extremes in Canada, as Vicky demonstrated. In a couple of provinces, electricity is already clean, zero carbon footprint for practical purposes, and affordable, cheap. That's Quebec and Manitoba. In Quebec, natural gas is also relatively expensive. So the ingredients are there to be able to immediately justify electrifying end uses with energy efficiency measures so that we keep the electrical demand down and the electrical bill affordable. And you can get return on investment immediately from the energy savings. You can get grants from utility, government, and even an electrical rebate. And sometimes you can switch tariff from a medium to a large consumer tariff. And instead of paying 7 cents a kilowatt hour, you may end up paying 5 cents a kilowatt hour. We've already looked at all that for customers, and we're doing this as we speak in some of our projects. Then at the other end of the spectrum, there's a market like in Ontario, where electricity is not carbon intensive, but it's expensive, and natural gas is cheap. So there, what we do is we try to set you up to be carbon neutral ready. If we can't electrify all end uses immediately, because electricity is expensive and it's hard to justify. NRCan's job is to provide clean, cheap electricity Canada-wide. When is it going to happen? We'll see how things pan out, but we'll set you up with that in mind so that you have something to offer to your clients if you can't get zero carbon operations immediately. And because electricity is expensive, we can leverage the fact that solar panels, on-site solar generation, will have a quick payback. And in Ontario, that becomes an option to consider, as well as reducing the electrical consumption by energy efficiency measures that target electrical end uses. Those all have a quick payback. So we focus on things that are good for your business and that provide return on investment, a roadmap which is feasible. And as Vicky described, with the, what's going on in the world around, and we adapt as we move forward. So some end uses can't be electrified because they require very, very high temperatures. In that case, we look at offsets. So we have lots of cards to play in our hand, and we know how to approach each different aspect and issue. Nikki?
Thanks, Antonino. So now we have another poll question. And I can't see the question anymore, but it has to do with where your organization is at in terms of its greenhouse gas planning.
I can read the question, Vicky.
Thanks.
Thanks, Vicky and Antonino. Does your organization have a science-based greenhouse gas target and plan? Please select one of the following answers. Not yet. Committed to a greenhouse gas target, not yet developed a plan. Committed to target, have a plan, not yet part of our business. Or greenhouse gas target and plan, including operationalization of the plan. We'll give you a minute to answer the question. And here are the results of the poll. It seems like most of your organizations have a greenhouse gas target and plan and have operationalized it with sort of equal answers on all the other sections. So it's interesting. Thanks, Vicky and Antonino, for your presentation on pathways to achieving net zero emissions. Next, we have Norm, who will discuss building resilience to the impacts of climate change.
Thanks, Kazem. And so I will talk here a little bit about climate change risk and how to handle that with climate change resilience. Wanted to highlight two key differences here in terminology. I think sustainability and resilience are two key areas to think about when it comes to climate change. Sustainability, the area around sustainability is well established, whereas the area around resilience is just kind of getting started in the area of planning and climate change risk. And from a resiliency perspective, this has to do with things like understanding the impact of external environment on assets, activities, services, and organizations, balancing efficiency with redundancy, and adapting to climate change. In general, resilience is considered as risk management. So this is essentially protecting the functionality, the value of your assets, the built environment, deriving income, or benefiting the public in some way. So why resilience? In general, there are impacts to built infrastructure, and our built infrastructure has been generated and built based upon historical codes and standards. And our codes and standards have been developed using historical climate data. And one of the biggest things that's happening here is that the climate is changing faster than our built environment can react to. We've seen this year with impacts in Western Canada and US, when the heat dome event happened, where impacts from extreme heat were exceeding the design of many different types of assets. In general, we have 3 plausible climate projection scenarios. These are essentially a business as usual approach. And then we have 2 other aspirational, more type limits, where we have a kind of mid-level intermediate emission scenario, and one where we would have to start acting now to mitigate and limit our climate change and temperature change to that value. Our current GHG emissions track on this business as usual track, and that you can see here with the red line on this figure that you see. In general, there are some common related code adaptations that are happening out there right now. And climate change adaptation parameters are being generated to help improve the resiliency of our currently built infrastructure, either through retrofits and renovations, or any new infrastructure that's being planned or built. In general, the types of adaptations that are being made to the code are around temperature, precipitation, wind, and snow and ice parameters. You can see them here on the left. But in general, we need to understand that for future climate to be integrated into our codes and standards, it's a new process and it's never been done. And it will take a certain amount of time to be able to integrate climate change information into codes and standards. So as we look further out, we can realize that our current codes and standards are going to become quite outdated very quickly at the rate of climate change. Why does this matter? There are some professional obligations for anyone who's working in the engineering space to consider essentially climate change. So Engineers Canada put out a statement that it's the engineer's duty to take all reasonable measures that engineered systems appropriately anticipate the impact of changing climate conditions. This can be through updated codes and standards, climate adjusted design criteria, or looking at climate change risk and resiliency measures through a climate change risk assessment. There are many reasons to do this, but many of these actually all tie back to monitoring and limiting legal liabilities when it comes to climate change risk. Other professional associations have a similar approach. The Canadian Society of Landscape Architects, Canadian Institute of Planners, the Royal Architecture Institute of Canada, and the Canadian Water and Wastewater Association all look to integrate climate change and climate change adaptation into their professional associations. So this joint statement here shows that each of these institutions is working to advance and shared understanding and ownership of climate change throughout their practice. Nicole mentioned earlier the Task Force for Climate-Related Financial Disclosure, and the process for the type of risk assessment that is done under this looks really at 2 different ways of climate change risk. We have kind of a negative view of risk most times, but there are also opportunities that come from risk. In this case, we're talking about transitional risks, so those would be change related to the changes and risk around the change from a high carbon intensive society to one that is more close to a net zero, versus physical risks, which come from the impacts of actual climate change events occurring at either an acute or chronic timescale. So acute events would be things like hurricanes, tornadoes, those types of events that are very rapid onset and can be very severe, whereas chronic events may be things like increased heat waves or increased mean temperature and how that impacts your operations. All of these tie together into financial impacts at the end of the day and can be looked at from a revenue or expenditure point of view. A couple of key thoughts here when it comes to climate and climate versus weather. When we're talking about climate change resiliency and climate, we want to make sure that we're focusing on kind of a long-term 30-year measurement of current climate. And so that looks back over a longer period of time that's either seasonal, annual, or multi-decadal, and often it covers a broad geography. This differs from weather and weather prediction in that weather really looks at our short-term days to hourly conditions, and they can change rapidly and are often much more localized. Climate looks kind of at the bulk signal of weather to understand essentially how the weather patterns might be changing over time. So climate can be considered as what you expect, so what we plan and design for in the long term based on our understanding of climate, whereas weather is what you get, and that can influence your operations, your maintenance, and at the end of the day, your costs. One other way of viewing this is that climate is like your wardrobe that you buy for a full year, whereas your weather would be your outfit that you pick out each day. So within the resiliency space, there's a standard approach for handling how climate change risk exposes your assets, operations, and staff. In general, we look at this through a 6-step process, which begins with a hazards assessment to identify the climate change parameters and hazards that might have impacts. And we look at your assets and say which assets might be exposed to all of these hazards. In that process, we then start to document impacts that come from the hazards on the asset. Any impacts that are documented are then looked at for their consequence. So we score this on usually a 1 to 5 scale to understand if something is very severe, so that would be a 5, or something might be kind of negligible and might fall out of our analysis at a 1. This all feeds into the risk assessment, which looks at the likelihood of a climate hazard compared to the consequence of the events happening. And that gives us risk scores at the end of the day, which lead us to our adaptation planning and our resiliency measure going forward. The risk assessment process kind of has 2 main components here, and I'll walk through this very quickly. The idea is that we have a threat, which would be our climate hazard, and then we have our elements that are at risk. So this could be your asset, your activities, your supply chain, your environment, your facilities. We ask ourselves, is any one of those things exposed to this one hazard? And if it is, we say, is it vulnerable? If it's not exposed at all, we move on to our next hazard that may impact the same assets. If it's vulnerable to that hazard, we then ask ourselves, what's the consequence when that hazard occurs? Is it something that's super severe that could destroy the asset, or is it something that just adds a little bit of additional nuisance that you might have to add your operations and maintenance cost up? If that happens, we also look at an intensity threshold where those occurrences start to actually cause an issue. So maybe there are 2 different types of storms that occur. One just gives you kind of that nuisance event, but the other might actually destroy your assets or your supply chain. So you need to have kind of intensity thresholds that allow you to look at these. And we bring those together, and that brings us kind of to our risk calculation. So that's the likelihood of the climate event times the consequence that we see. I'm going to go through a kind of really idealized example here using a community that you might imagine is nearby a site that you work in, or it could be even your hometown. This bridge here in the middle is going to be what we're going to focus on in terms of how climate might impact it. So under normal conditions, our bridge kind of sits with a certain load and capacity that it was designed for. So it has a capacity with probably a safety factor that's built in and a load that's consistently on it and used to be under normal operating conditions, that's what we hit. If we introduce different types of climate events into this scenario, if we look at our bridge and we introduce this first rainstorm, what we've seen is that the river has gone up and we've started to impact potentially the piers and some of the footings and the ground beneath the other piers. This actually starts to increase the load on the bridge and decrease the capacity of the bridge in some ways because you've added an additional load from a climate forcer. But we're not getting past our capacity, so we shouldn't really see any major impacts to our bridge. We may just have to consider that we might have to slow down when we cross it. In a more severe scenario here, we have a larger storm, bigger event overall. Maybe this is a 100-year storm. We've actually induced some sort of failure to the bridge. And really what this is demonstrating is that there are different types of storms that have different impacts, right? So our idea here is that we've added so much additional load that we've caused a failure of the bridge and some of the supporting infrastructure around. And so this could be a vital link to our community or to our assets, and we can no longer use it in this scenario. So risk classification and treatment is treated in kind of a 5-step group here, so going from negligible all the way up to extreme. Importantly here, when we have a negligible or low risk that comes out of this risk analysis, we often say that we don't need to put priority controls or priority risk treatment measures there in order to handle those risks. Those risks might become something that is additive to larger scale risks or combined with other types of parameters. If you have a combination event, maybe that causes a larger risk classification or a higher risk classification. But in general, unless something rates as moderate or higher, we don't really worry about adaptation measures. Once you get up to extreme, this is a situation where you're likely worrying about permanent damage to assets, and you really need to have adaptation measures in place right away to improve the resiliency of your asset or components. And just a quick example here of what this looks like. We'll use a flood as an example here. And in this case, we have a flood that is something that's very catastrophic. So on our vertical axis, we're looking from 1 to 5. 5 is very high in terms of its impacts. So the probability of that event is kind of low. It might only be a 100-year flood, but when it happens, it's quite severe. But what climate change is doing is influencing the change in the frequency of these types of events. So we might be going from something that is historically a 1 in a 100-year flood and turning it into something that's more like a 1 in 25-year flood towards the mid portion of the century. As that happens, we need to start planning for adaptation measures so we can reduce our overall risk and actually bring ourselves to a manageable risk level that we don't have to worry as much about. Even if the frequency is increasing, we won't lose our assets. And finally here, just one idea of thinking about this is cascading impacts and potential spots where we can have interventions. So in our scenario here, starting on the left, we have a severe winter storm that's causing loss of power and loss of local power at centers. And then that is starting to cause impacts on our assets and our services. So we have service and operations that are interrupted, and there might be some issues with supply chain being interrupted because our other partners and manufacturers are having trouble getting us product as well. This could lead at the end of the day to a loss of revenue and customer complaints and potentially a reputational risk. There may be an opportunity to use some backup power to continue core operations, but not everything will be able to function off that. At the same time, access to site and transportation is limited, and there are some health and safety concerns. We need to clear snow and ice and have some enhanced operations to clear that up. And we also need to have increased operations and maintenance costs to recover. So we have a couple of places where we can start to intervene here. So at first, we can think about our adaptations. So can we introduce an adaptation measure that helps us deal with loss of local power at centers? Could that be increasing our base of suppliers for certain materials so that we don't lose, at the end of the day, our revenue because we don't have a supply? There are other ways too, where we can just try to manage some of these impacts. So using backup power here is a management strategy, where we can use backup power to continue our core operations and hopefully ride out the storm. And there are other things to monitor along the way so that we can do better planning. So knowing that this type of event causes increased O&M, and if it is going to become more frequent, we can do a financial analysis to understand how much more frequent and costly these types of events will be into the future. In general, you can handle all of this either through emergency plans or sometimes just supply chain redundancies that we don't wind up having as large of a loss of revenue. And finally, best practices, I'll give some examples here in Canada. From the climate change risk assessment perspective, ISO 31000 is kind of the standard for risk management. You see that not just in climate change risk assessment, but in all risk assessment. And there are a bunch of tools here listed that are used, including the climate lens. You might see the PIVC protocol and ICLES, BARC, building adaptive and resilient communities. These are all different frameworks that you might be able to use to help assess climate change risk. With that, that brings us to our third poll. So this is what types of climate change hazards currently cause impacts to your assets, activities, and infrastructure. And I believe you can choose, I guess, one of the following.
Thanks, Norm. I'll give everyone a chance to respond. And here are the results. It seems that most people have chosen severe thunderstorms, including hail and tornadoes, as the greatest hazard to their assets, with extreme heat and cold as coming in as a second. Thanks, Norm, for your presentation on building resilience to the impacts of climate change. We'll now go to the chat box for your questions. Our first question is for Nicole. How do I know what ESG initiatives or targets my customers may expect me to undertake?
So, until there's that official notification or that signal from customers, it can be very difficult. One of the things that I can suggest is go to the Science Based Target Initiative. They have a very handy search tool that allows you to search both by company name, and you can even look at some of the commitments within the sector that you're servicing or the sector of your competition, and it lays out targets that have been set. The other suggestion I'd make is look at annual sustainability reports. You will find that they identify what their material topics are and how they are going to manage them. Often there's a piece there on procurement and how they will push supply chain or sustainability down through the supply chain. And you can also look at financial reports in the material risk section. Sometimes that has identifies high risk items, and while it may not have the requirements for your facility, you may need to read between the lines that if there's a risk, they are going to begin to manage it.
Great, thank you, Nicole. I think we have time for another question. This one is for Vicky. In order for a manufacturing facility to claim net zero, must it include both Scope 1 and Scope 2 emissions?
In order to develop a plan, the best practice would be to look at all three scopes and set some targets around that. But I mean, there's nothing stopping you from claiming net zero Scope 1 emissions. I would just suggest that you be explicit on what your target is, and if you're able to achieve net zero with your Scope 1 emissions, those are your direct on-site. So I mean, that would be a great accomplishment in itself, but target setting around all three would be important. Ultimately, someone else's, your Scope 3 emissions are someone else's Scope 1 emissions. So if we all were to set targets on our Scope 1 emissions of net zero, then theoretically we could achieve net zero as a global economy, but setting targets around the other scopes can help to push your suppliers in the right direction as well.
Thank you, Vicky. That looks like all the time we have for questions for now. Please feel free to reach out directly to our presenters or myself with any other questions you have, or to talk more about your own project or corporate requirements. Thank you to everyone who joined today's session. A recording of the webinar will be sent to each of you, along with the contact information of each of the presenters. We would sincerely appreciate your feedback on today's presentation, along with any requests for future sessions that you'd be interested in. Until next time, on behalf of Nicole, Vicky, Antonino, Norm, and the rest of the Stantec team, Thank you for your time.